Welcome to my channel. In this session, we will discuss the second part of selections or combinations. In the first session, we have discussed the basic concepts of combinations or selections. We have discussed the basic formulae and how to calculate them and all that. In this session, we will apply those formulae, those basic concepts and solve different types of questions. And this is the third in the series of these permutations and combination videos that we are making. The first question, find the number of ways of selecting a team of 3 persons from 6 men and 4 women. We have 6 plus 4 total 10 persons and we need a team of 3 persons. Here, there is no specification that the team should have this many men or this many women. Since there is no condition as such, it is as good as simply selecting 3 people out of 10 people, that is 10C3. Selecting 3 persons out of 10 is 10C3, and you know NCR formula is n factorial by n minus r factorial into r factorial. If I apply the formula here, 10 factorial by 10 minus 3, 7 factorial into 3 factorial. 10 factorial by 7 factorial will be 10 into 9 into 8, because 1 to 7 here, 1 to 7 here will get cancelled. By 3 factorial, 3 into 2 into 1. 3 threes, 2 fours, 10 threes, 30 into 4, 120. So the total number of ways is 120. Total number of selections possible, we have here 120. Let's take up next one. Find the number of ways of selecting a team of 5 persons from 6 men and 4 women such that a particular man and a particular woman should be there always, should get selected by themselves. That means out of total 10 persons, you have to select 5 people, but one particular man here and one particular woman. So for 2 people, you have no option but to select them. That means out of 10 people, only 8 people you have some choice of either selecting or not selecting. Since I need to select 5 people, out of which already 2 people are definitely there, so we have to only select remaining 3 people. So it is like selecting 3 persons out of the 8 people. Out of 10, 2 are definitely there. So the remaining 8 people, from 8 people, I have to select. Out of 5, 2 already got selected, means I have to select 3. 8C3. 8C3 is nothing but 8 factorial by 8 minus 3, 5 factorial into 3 factorial. 8 factorial by 5 factorial is 8 into 7 into 6, because again 1 to 5 here, 1 to 5 here will get cancelled by 3 into 2 into 1. 3 to 6, 6 gets cancelled. My answer is 56. Let's take up one more. There are 8 batsmen, 3 wicket keepers and 7 bowlers available for selection. How many ways a team of 11 players can be selected such that the team consists of 5 batsmen, 1 wicket keeper and 5 bowlers? We have how many batsmen here? 8 batsmen, and we have wicket keepers 3, and we have bowlers 7, and we need to select how many people? 11 people. But what should be the composition? There should be 5 batsmen, 1 wicket keeper and 5 bowlers. Out of 8 batsmen, you have to select 5 batsmen, means number of selections is 8C5. Out of 3 wicket keepers, 1 should be selected, means 3C1. And out of 7 bowlers, we need to select 5 bowlers, 7C5. If you multiply 8C5 into 3C1 into 7C5 is the total number of options. Because if you recollect the first class, if one job can be done in m ways, another job can be done in n ways. How many ways both can be done means m into n ways. The fundamental principle or the multiplication principle. Similarly, we have to select these 5 batsmen and 1 wicket keeper and 5 bowlers, means all these 3 have to happen, means total number of options are 8C5 into 3C1 into 7C5. 8C5, if you calculate, it will be 56. 3, you know how to calculate, you know the formula, NCR formula, you can do the calculation. 3C1 is 3, 7C5 will be 21, 7 into 6 by 2, that is 21. So now 21 into 3, 63, 63 into 56 means if you multiply this, 6 3 is 18, 3 5 is 15 plus 1, 16 plus 6, 36, 52, 6 5 is 30, 3 5 2 8. So the total number of options I have is 3 5 2 8. Let's take up one more example. Find the number of ways of selecting a committee of 5 persons from 5 men and 3 women such that the committee consists more men. You should have more men than women. See, now I need a committee of 5 persons and we need more men means out of 5 men and 3 women, probably we can have all men. So what are the options I have? There are 3 possibilities. One option is I need a committee of 5 people, all 5 can be men. This is one option. Second, there can be 4 men and 1 woman. Out of these 5 persons I have to select. Third option, there can be 3 men and 2 women. That's it, because the fourth option is not there, because it can't be 2 men and 3 women because we need more men. So these are the possibilities. Either this, I should have either this possibility or this possibility or this possibility. Now, how many ways I can select 5 men? Out of 5 men, I have to select 5 men means 5C5, that is 1. Out of 5 men, I have to select 4 men means 5C4 into, out of 3 women, 1 woman will be 3C1. As I have already said, 5C4, you know how to calculate. I'll take directly 5, 3C1, 3, 5 into 3, 15. Next, the third option I have is, out of 5 men, I have to select 3 men means 5C3. Out of 3, 2 means 3C2. 5C3 is 10, 3C2 is 3, total 30 options. So now the question is, all these 3 options don't exist. Either this or this or this. It's not this and this and this. So either I have a committee of 5 men, or I have a committee of 4 men and 1 woman, or I have a committee of 3 men and 2 women. When we have or, we should add it. And means you should multiply. So it will be 1 plus 15, 16 plus 30. Total we have 46 options. Right? So these are few examples on selections. In the next session, we will discuss about arrangements. Thank you.